Now that we've taken a general look at what a sinusoidal function is, now we're going to look into two very specific kinds. We're going to look at the sine graph, and we're actually going to look at the cosine graph too. So because we've dealt with them since Foundations 10, we'll kind of deal with kind of their general characteristics. So when we look at the sine function, there's a few key things. Now, if we're going to be talking about two different things, we can talk about it in degrees, or we can be talking about it in radians. So degrees being, well, degrees. The key characteristics on degrees in general are split into 90-degree sections. 90, 180, 270, and 360. Of course, alternately, we can also have negatives. So negative 90, obviously this would be 0. Negative 180, negative 270, and negative 360. Our sine graph. So when we actually graph the sine function, one more key characteristic, and try and make it as much to scale as possible, -1. The sine graph looks like this. Starts at 0, goes all the way up to 1 at 90 degrees, crosses back down the x-axis at 180 degrees, goes down to its lowest point at 270, and comes back up at 360. Now, of course, I know that doesn't look the greatest. Hopefully, when I do it in radians, it'll look good. Now, it can also start at 360, go up to 1, cross, down, and back up. That one doesn't look too terrible, so I'm actually going to delete this part. And I'm going to clone this. Where's my clone? There we go. Just because it looks a little bit better. Actually, I didn't do too bad with making it to scale. If I do this in radians, it's still going to go up to 1, and down to -1. The only difference, though, I'm actually going to make this probably a little bit bigger. It's still split into 4 sections. The only difference, though, is 90 degrees in radians is pi over 2, or about 1.57. 180 degrees, as we had done in section 1, is pi. So pi over 2, and therefore 360 will be 2 pi's, or 6.28. We can go alternately backwards. -pi, -3 pi over 2, and -2 pi. We can do the exact same characteristics. Now, normally I do start at the y-axis, or the origin, 0, 0. Goes up to 1 at half a pi, crosses back down the x-axis at pi, goes down to its lowest point at 3 pi over 2, and back up at 2 pi. I can continue that backwards. And it looks like this. Now again, those of you that have taken physical science will maybe remember a little bit about waves, and that's exactly what these are. It's a wave. And that's one of the things that we'll talk about in the important notes. So a sine graph is also known as a sinusoidal curve, which is a curve that fluctuates back and forth like a sine graph. It fluctuates back and forth, back and forth, back and forth, back and forth, all over. In other words, a curve that oscillates back up and down from a center line. The graph of the function repeats itself, then the function is said to be periodic. Now, you'll notice, absolutely, a wave is a type of sinusoidal curve, or a periodic curve. Periodic function is a function that repeats itself, so they're basically saying the same kind of thing. Some key aspects to note, and we had talked about this in previous section, that the period of a curve is the angle measure required to pass through one complete cycle. So the length of an interval over which a graph repeats itself. One cycle is one crest and one trough, one up and one down. If a periodic function has a maximum value of m and a minimum value of lowercase m, then its amplitude is max subtracting min divided by 2. Now we're going to describe this sine graph. So if we describe the graph of y equals sine x, or y equals sine theta, its range talks about our y's. And if we look at it, our lowest value that it hits is -1. Its highest value that it hits is +1. So our range is -1 is less than or equal to y, which is less than or equal to 1, y being an element of the real numbers. So that's its standard range. The midline, you can see the middle line that cuts this graph in half is the x-axis. And because of that, it means that it has an equation of y equals 0. Because all along the x-axis, y equals 0. The amplitude. So as we had talked about in previous section, our amplitude is measured from our middle to its highest point, or from the middle to its lowest point. And in this case, it's 1. So the amplitude is 1. And the period is how long it takes to repeat itself. And as we had discussed before, we can measure one thing from the middle till it repeats itself back at the middle. In this case, it's 360 or 2 pi. So 360 degrees or 2 pi. The standard one that we'll be using a lot of is this 2 pi. It has quite a few applications, and we'll kind of deal with that when we get into a word problem. All right, we're not limited to just sine graphs, because we can also have cosine graphs. And a cosine graph is split up very similarly. 0, let's see, try and make this as proportional as possible. 180, 90, 270, 360, and of course we can go back. That will be -180, -90, -270, -360, and might as well, while I'm here, go fill in this one too. Pi over 2, pi, 3 pi over 2, and 2 pi. Obviously, we have 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We'll use the same kind of characteristics, 1 and -1, 1 and -1. Here's the difference for the cosine graph, though. Instead of starting down at the origin, the cosine graph actually starts up at 1. at 90 is when it crosses the x-axis. At 180, it would hit its lowest point. At 270, crosses the x-axis again. And at 360, it hits its highest point. We continue backwards. Oh, that's terrible. I gotta erase that part. It creates still that same kind of wave format. Now, we don't have to technically start at 1 because we can start back. Normally, we do start at the y-axis, but either way, their equivalent angle measures in radians perform the same characteristics. So what I'm saying is 90 degrees in degrees is an x-intercept. Pi over 2, which is its radian measure, is also an x-intercept. So let's talk about a few things. Let's talk about the range. Well, on here, our range, our lowest value is -1, and our highest value is +1. Our midline, the line that would split this graph, either of these graphs, again, we have one in degrees and one in radians, is still our x-axis, which is the equation y equals 0. Amplitude. We measure it from the middle to its lowest point or from the middle to its highest point. Well, it's a good thing, those are 1. The amplitude is 1. And the period, oh, sorry, I'm going to stick with the same colors. Our period is how long it takes to repeat itself. So either we can measure from the middle until it goes back to the middle and repeats itself, or another way that we've done it before is to measure from the top of a crest to the other top of the crest. Well, we can measure that as 360 degrees. Or its same equivalent in radians is 2 pi. But we're not limited to just that because we could also measure from the middle till it repeats back to the middle. And -90 to 270 is still 360, or -pi over 2 to 3 pi over 2 is a horizontal distance of 2 pi. And of course, the last way that we've done it, wow, that's really uneven. I'm gonna actually fix that. Just to make it actually look a little bit more, I'm still not happy with it, sorry. Lowest point is -1. There we go. Either way, we could also measure from the bottom of the trough to the bottom of the trough, which is -180 to +180, which is still 360. So you'll notice that the characteristics for a sine graph and cosine graph are the exact same thing. At the same time, you'll notice one other thing that we'll come back to in a second. So let's talk about a few things. We are going to talk about some transformations. Now, I'm going to add a little bit of extra space in here. Yeah, I just wanted to make that a little bit nicer. So on your version, it'll look a little bit better. All transformations come in this shape. And first off, we're going to talk about 2 of them. We're going to talk about the A and the B. So if you have a number in front of a sine or a number in front of a cosine, it's known as a vertical stretch, which means on a vertical scale, it's going to be getting bigger. And if I show this, it's going to get bigger vertically. Now, the amplitude is actually affected by that vertical stretch. Now, the symbol for it is absolute value, It just means that whatever the number is, the amplitude is still going to be positive, because it doesn't matter whether you're measuring from the middle to the top of a graph or the middle to the bottom of the graph, it's still going to be the same kind of amplitude. A negative would just change very slightly, though we'll kind of work some different ways of getting around it, unless you've taken pre-calc 30, which this actually comes right well into our wheelhouse. Now, there is the B value indicates a horizontal stretch. Now, a horizontal stretch actually means that we're going to be dividing 2 pi by b, or taking our 2 pi, which is the normal period of both a cosine and a sine graph, and multiplying by 1 over b. So we're going to deal with some characteristics and deal with some things that are like that. Yeah, the amplitude is a vertical stretch. Period is also that. Since single period is normally 360 or 2 pi, we would just divide it by b or multiplying by 1 over b. Alrighty. So let's deal with a few. So we're going to find out the period and the amplitude of these two things. So the normal characteristics looks like this. We'll get to the h and k in just a second. So either we can substitute sine or cosine in. The period is affected by the b value. So whatever number is in front of the x. So the period, how long it takes to repeat a single oscillation or a single time to go up, down, and back, just takes 2 pi and divides it by the b value. In this one, it's 2. So 2 pi divided by 2 is just going to be pi. The amplitude is affected by the a value. So the a value is just going to become 2. And that's, again, measuring from the center to the top or from the center to the bottom. Our period in this one is going to be 2 pi divided by 3 over 2. Well, 2 pi divided by 3 over 2, because dividing by a fraction is a nice grade 8 skill. Dividing by 3 over 2 means multiplying by 2 over 3, which makes it 4 pi over 3. And our amplitude is affected by the a value. Well, there is no a value, which means it's 1. R1 here. Period is going to be 2 pi divided by whatever the b value. So the number in front of the x is a 4, which means we reduce it down 1 and 2, pi over 2. Our amplitude is our a value, which is 3. So what we're going to do here is we're going to actually graph these characteristics. So it's going to make things look slightly different, but at the same time, it's going to be very similar. So first things first, what I always do is when I do my sketches, I always indicate what type of graph I'm doing. I'm doing a sine graph. Because I'm doing a sine graph, I need to know what a sine graph looks like. A sine graph starts at the middle, goes up, down, and back. In the period, that is normally 360 degrees. Its x-intercept is 180 degrees. Well, we calculate our period in radians. So let's do that right. That's 2 pi, and that's 1 pi. Now let's do some sketching. So it says that our period, how long it takes a sine graph to repeat itself, is pi. Well, normally it's 2 pi. Well, the good thing is we don't actually have to do too much too many special things, especially if there's no scale on it. All that we have to do is we're still going to split it into 4 sections. Both the sine and cosine graph work best splitting into 4 sections. The only thing that's going to change is instead of this n value being 2 pi, it's just going to be pi. So this value over here is going to be pi, which means if we split this evenly, this would be a half pi, this would be a quarter pi, and this would be a 3/4 pi. Obviously we have 0. And we'll continue backwards as well. So this would be negative pi over 2, pi over 4, negative 3 pi over 4, and pi. We are also going to adjust our amplitude. The normal amplitude for a sine graph, again, I'll go back to the one here, is normally 1, because measuring from the center to its highest point is 1 unit. For this one, though, we've calculated it as 2. Well, not really calculated, but identified it as 2. So the only thing we're going to do is change the amplitude. Its highest point is going to be 2. Therefore, its lowest point would have to be negative 2. So when we do a sketch of the graph, our sine graph starts at the middle, goes up to its highest point, literally halfway in between our 0 and our first half. So this point, that point is that one. So when we do a sketch, it's going to start here. It's going to hit its highest point in this one at pi over 4. It crosses the x-axis halfway in between our 0 and our period. So that will be right there. So if we do a nice sketch, it's going to come up. It's going to come back down to cross. Its lowest point is going to be halfway in between the halfway point and the period. It's going to be about right there. Connect the dot. And we come back up. I know it doesn't look very nice, but it is also as best as we can. If I had a nice grid, I might be able to do it a lot nicer. But I can still continue on because this graph would normally go up, down, and back. And it would keep on going back and forth like a wave, which means on this one, I can continue back, do the exact same characteristics as this one. Hey, that one looks really bad. I'm going to fix that. If I ask you to sketch something, I'm not expecting it to be perfect, but it should look good enough to be easily identified as a sine graph. Alrighty, next one. Cosine of 3 over 2x. Well, our period in this one is 4 pi over 3. So let's split it nice. So the time that it takes to repeat itself is going to be 4 pi over 3. Halfway, split 4 pi over 3 into 2, it would be 2 pi over 3. This one works out really nicely. And it's really split up very perfectly. But either way, sine and cosine graphs get split into 4 things, into 4 sections. Negative 4 pi over 3, that would be negative pi, negative 2 pi over 3, and negative pi over 3. We've identified for this one that its amplitude is 1. So let's see, that's going to go 1, its low point, it's going to be 1. But let's take a pause and identify what a cosine graph looks like. A cosine graph starts up at 1, goes down, and back up. Obviously, backwards, it would still continue on and on and on and on. Its normal period is 2 pi. Halfway in between on this one, it actually hits its lowest point. Halfway in between here and here, crosses the x-axis, and halfway in between here and here, it also crosses the x-axis. So we're going to do that same kind of characteristic here. It's going to start up at 1, it's going to cross the x-axis at that first point, go down to its lowest point, halfway in between its 0 and its period, come up, crosses the x-axis, and then hits this highest point. We can continue that on the left-hand side of the y-axis and get the exact same graph, or the continuation, the periodic motion of this sinusoidal function. And that's a cosine of 3 over 2x. On our last one, we're going to identify some more things. Our period here. Well, we've identified by taking that 2 pi divided by that b value is pi over 2. So let's put that in. I'm going to split this into 4 equal sections. Pi over 2. This one would be negative pi over 2. Half of pi over 2 is a quarter. Split this one again. We have pi over 8. And this would be 3 pi over 8. These key points are the ones that I really want you to be able to graph or be able to identify, because it makes your graphing a lot easier and a lot more accurate. Obviously, this one would be negative 3 pi over 8. This one would be negative pi over 4. Okay, what's its amplitude going to be? Well, it's the number in front, our a value, which is 3. So its highest point is 3. Its lowest point would then be negative 3. The cosine graph, once again, starts up, crosses, and back up. The entire period, 2 pi, halfway in between its lowest point, halfway in between these two, it's the x-axis, our x-intercept, and halfway in between here and here is also the x-axis, x-intercept. So I know that I'm going to be crossing at those 2 points, and those 2 points. So when I start off my sketch, down to bottom, center, up. And I know it doesn't look perfect, but it is also as best as we can. But if you have a grid, you'll be able to do it a lot nicer. And I tried providing that for you for assignments as best as I can. You'll notice that it doesn't exactly cross. I can adjust it. But I want you to be as accurate as you possibly can. On this one, we're going to actually determine its equation. So once again, our general form, y equals a sine of b x subtract h plus k. Again, we'll be getting to the h and k in just a second. Let's identify a few key characteristics. First off, what is the period? And what is the amplitude? Well, the amplitude is going to be probably the easiest one to identify. At the same time, period is also quite easy. Amplitude from the center to its highest point. Well, it says each point is worth 1, so its amplitude would have to be 3. Our period is how long it takes to repeat itself. So over this entire course of this periodic function, sinusoidal function, our wave, well, it's 8 pi. Because it would continue on. Because I could take this. Oh, look, it would continue on. And continue it on back. But it continues on. The tricky part to this one, though, is identifying what is our A value and what is our B value. The A value is probably is absolutely the easiest one. Actually, I should probably move this down slightly. The A value is exactly what our amplitude is. It's 3. But our B value is a little bit trickier. Now we can put it in brackets, we don't have to, but at least not yet. Our B value is calculated by taking 2 pi divided by some number. Well, our period is 8 pi. So a quick way of calculating it out is setting up a proportion. So by doing proportion, 8 pi multiplied by b will be 8 pi multiplied by b. 2 pi multiplied by 1 is 2 pi. I can divide by the 8 pi. And our b value, let's do some reduction. 2 and 8, we have 4 and 1. The pi's would cancel off. Oh, our b value is 1/4. So our b value here is 1/4. Now, how does that make sense? Well, it's actually just saying 2 pi divided by our b value of 1/4 gives us what the period would be. And you could calculate it by decimal, you can calculate by strict calculation. So 2 pi dividing by 1/4 means multiplying by its reciprocal. 2 pi multiplied by 4 is 8 pi. Now, technically, you don't have to always do it this way. You could try and work it out in your head, saying 2 pi divided by what gives me 8 pi? Well, the calculation gives you it for sure. You may have to do some trial and error in your head to find out what your b value is here. All right. But we're not limited to just using our A and B values. We're also going to be working with the H's and K's. So our A and B values still stay the exact same. Our A value still talks about our vertical stretch, which affects our amplitude. Our B value affects our horizontal stretch, which is our 2 pi divided by the B. Now the H and K values, I know in the textbook, they actually use a capital A, capital B, and instead of H, they use C, and instead of K, they use D. I just like using the same kind of terminology between my pre-calc courses and my foundations courses, and that's why I use the H's and K's. Again, make sure that I adjust this down, but that's just a cosmetic thing. But when we do our graphing, what we're going to be doing is we're also going to be talking about a horizontal or a phase shift and a vertical shift or translations. Now we had talked about a little bit of that in Foundations 20 when we talked about graphing our quadratics. Same time we had talked about different translations in grade 8. So overall, what it does is this H value, I use the phrasing just like I use in Foundations 10 and in Foundations 20, opposite on the inside, same on the outside. Now that actually applies directly between our B and H and our A and K because they're so tightly related to each other. So when I say opposite on the inside, it means whatever thing is on the inside. So this is X subtract a value. Well, if it looks like it's subtracting, because the inside is going to deal with a horizontal. See that the B and H are also talking about horizontal. Actually, sorry, I'm just going to change that color. Whereas the A and the K talk about verticals. If it says a subtraction on the inside, what we're actually going to do is we're just going to do the opposite. Just like here, it looks like this is a multiplication. We're actually dividing by the b. So whatever it says on here, it says adding, it says addition, we're going to actually move left. So if it's x add a value, we're going to go left. Whereas if it says x subtract something, we're going to move right. Vertically, if it says positive, it's going to move up. And if it says a negative, it's going to move down. So let's get into some examples so we can see what all this really means. So we're going to consider the function 2 cosine of 4x add 1. Now we're just going to be concerned from 0 to 2 pi. We're going to describe any shifts that occur, all that kind of stuff, described by determining amplitude, midline, range, period. And then we're going to do some graphing. So let's look at any shifts here. Well, first off, there is no number inside that's being subtracted on the inside. That is all on the inside. So there is no horizontal shift. But this k value, there absolutely is one. So it's a vertical shift or a vertical translation. And it says positive 1 plus 1. Well, it's positive, we're going to be moving up. Which means the entire graph, which actually is just this 2 cosine 4x, is going to move up 1. So we're going to determine a few things first. Let's talk about the amplitude. Well, our amplitude is affected by our a value, so our amplitude is going to be 2. Again, measuring from the center to its highest point, or from the center to its lowest point. Both the same thing. Equation of the midline. Now that's a new one. The normal midline for a cosine graph, the normal midline, because the cosine graph starts up, goes down, and goes back up. That midline is the x-axis. But what has happened to this graph? The graph has moved up 1, which means instead of having a midline of the x-axis, our midline would be y equals 1, which is also going to affect our range. Because instead of having a range of -1 to 1, which is normally what it would be, we've had a few things change that. First off, we've changed what our midline is. And at the same time, we've also changed what our amplitude is. Remembering for the amplitude, we always measure from the middle to the highest point and from the middle to its lowest point. If our midline is 1, the lowest point will be taking 1 subtracting 2, which is -1. From our midline to its highest point, we'd be adding 2, which means it would be going all the way up to 3. So the range on this one would actually be from -1 to +3. Last one thing that we need to identify is our period. And our period here is normally 2 pi, but it's affected by whatever our b value is. In this case, it's 4. If we reduce it, it's half a pi, because 2 and 4 reduce to be 1 and 2. Now we can do some sketching here. So the normal period is 2 pi, and this one, it's half a pi. Which means we're going to still split this into 4 equal sections. I know I say it from here. Actually, I'm going to change this. Actually, no, I'm just going to take all this out. None of this really needs to be here. I'm just going to change the wording. Graph for 2 periods. So I'll change that up for future years. All right. Now let's get into this. So this would be negative pi over 2. This will be pi over 4. This one will be negative 3 pi over 8. Negative an eighth pi. Positive an eighth pi. 3 pi over 8. Now, we have a few characteristics that have changed. For example, our midline is now 1. So I'm just going to draw a dashed line to help us deal with it, just the general idea of what it's going to be. Instead of this midline being the x-axis, it's going to change. At the same time, our range has also changed. Instead of being from -1 to 1, or an amplitude of 2 being from -2 to +2, our range is going to be from -1 all the way to +3. So we've put in our midline, we've identified our change in our amplitude, change in our range, we've identified our period. One thing I haven't said yet is that we always make sure we apply these stretches because they're really a multiplication or division. Multiplication division comes before addition or subtraction, which are these translations. So we're always going to make sure we do A and B before we do the H and K. So now let's do a sketch of this. Cosine graph always starts up, goes down, and back up. So we can identify a few key characteristics. It's going to start here, and it's going to end here. Now our x-intercepts are not going to be perfect because, first off, our lowest point here is halfway in between our 2 high points. So it's right there. That is not our x-intercept. Our x-intercepts, which would, without our adjusted midline or our vertical translation up 1 unit, our x-intercepts would normally be these 2 points, but they're not. Those points are where they would actually cross our midline, our y = 1. So those are the points that are going to adjust. Of course, we're not going to be perfect. We're not going to be able to cross our x-axis, but we can cross our midline at the proper points. So that's going to cross there. When it comes back up, it's going to cross that midline right there. We continue on. Again, those normal x-intercepts would normally be right here and right here. Because everything got moved up, they're going to cross at those 2 locations. So when I graph for 2 periods, we get a graph that looks like that. Now I have another one. So here is our graph for 2 periods of our 2 cosine of 4x add 1. Actually, I'm going to change this. I don't like 45. I want pi over 4. Again, I'll check this out. Graph for 2 periods. All right. Let's do a few things. So first off, we're going to describe any shifts that occur. First off, the shifts, well, it's this one. That is a horizontal shift. Horizontal shift. It says x subtracting pi over 4. X subtracting pi over 4. So if we go back, if it says subtracting, it's actually going to be moving right pi over 4. So horizontal shift or translation, right pi over 4 units. That is the only one that's in here. Yeah, we might as well make this fun. Let's add a subtract one here too. And we have a vertical shift or vertical translation. This is, we'll put that subtract one at the end. So our full graph is actually going to be y equals 3 sine of 2 bracket x subtracting pi over 4, subtracting 1. So that's what the actual graph looks like. I'll make sure that my versions actually look better on yours. It means it's going to be moving down 1 unit. So let's identify a few key characteristics again. Our amplitude. Amplitude is whatever our A value is. And this one, it's 3. The equation of the midline. So the midline is affected by that vertical translation. Just like we in our first one, the sine graph, which normally starts at the middle, goes up, down, and back. Now, this -1 means that the midline, which is normally the x-axis, is going to be the line y equals -1. For our range, because our midline is -1 and our amplitude is 3, we can identify what its lowest point and its highest point would be from that midline. -1 subtracting 3 is -4. -1 adding 3 is +2. So our new range would actually be between -4 and +2. And that is our new range. The period is done by taking 2 pi and dividing by whatever b value is. In this one, it's 2. So 2 pi divided by 2 is just going to be 1 pi. So let's do some fancy maneuvering here. I'm going to split it into 4 equal sections, both positive and negative. Our normal period is 2 pi. It's now pi, which means we have pi over 2. This would be 3/4. This would be 1/4. -1/4, negative pi over 2, -3 pi over 4, and negative pi. Our highest value is going to be 2. The lowest value is -4. So when I split this up, just so I can have it as best a scale as possible, -1, -2, -3, I can do my graphs and my sketches a lot nicer. So first things first, our midline of -1 Well, that's where everything is. See, what other things can we do? Well, let's see. We know what our amplitude is going to be. We're going to have to make sure we go from our midline. We're going to have to go all the way up to 2 and all the way down to -4. Our period has been affected. Our vertical shift. Everything's going to be moved down 1. So instead of starting here, everything's going to be shifted down 1 unit. But that's not it. It's also been moved right pi over 4. So that point is instead right there. From that point, we're going to have to do a sketch of a sine graph, which goes all the way up, down, and back up in the span of 1 pi for this one. Now, if you're following along, you're sketching in your own, please do not do this, because we can't do this. We can't go and say that. No, we cannot do that. The reason for it is multiple things. First off, this is not started and ended at the middle. We have to start and end at the middle for a sine graph. The next thing that we need to identify is we are not starting and ending in the span of 1 pi. We've actually started and ended in the span of 3/4 of a pi. And actually even less. Because from 1/4 pi to 1 pi is 3/4, even if we put that down to the middle. So let's do this right. Oh, come on, there we go. Identify a few key characteristics. It has to start and end in a span of 1 pi. Well, that's 1/4 pi. That would be 1/2 pi. That's 3/4. Our next point, which may not be the easiest to graph, especially with our sketch here, it has to both start and end at that midline, just like this one does. From 1/4 pi to 5/4 pi, it has been able to start and end. Next thing we can identify is that mid value, where we cross the x-axis, but our x-axis has moved down 1. So our x-axis has moved down 1. It's going to cross our new midline halfway in between, which this one is 3/4. We hit its highest value halfway in between these two, which is at 1/2 pi. And we hit its lowest value halfway in between these two, which would be at 1 pi. After we've identified those key characteristics, those key points, then we can actually do a sketch of the graph. That way we have a properly sketched sine graph. If we do the same thing back, well, it's going to have to repeat itself. So if we go back 1 entire pi, that's 1/4, that'd be 1/2, 3/4, 1 pi. We'd be having it here. Halfway in between, well, that one's there. Our highest point and our lowest point. Connect our dots. So we can have a properly graphed 3 sine of 2x subtract pi over 4 subtracting 1 graph. This is this sinusoidal function. It takes a bit of meticulous understanding and meticulous work, but it can be done. It just takes time, and it takes practice. Now, noticing from here, it would be very hard to identify exactly what our x-intercepts are. I mean, if we have graphing technology, we could approximate and we could do a few calculations. Pre-calc, we can do some more things as well. But this one's not really the easiest. But we could identify exactly what our y-intercept is because it works out perfectly with our graphing. Yeah, our y-intercept is -4. But just so you don't have to be too particular with your x-intercepts unless they actually cross out nicely or cross nicely, just the same as this one. We can't perfectly identify what our x-intercepts are, but this one works out greatly to identify what our y-intercept is. All right, these ones. We're gonna have to do some work. What I usually do is when I want to find out an equation, I always try and identify what my midline is first. My midline, see, its lowest point here is -7. Its highest point is 1. Halfway in between is -3. Y equals -3. Which means this has moved down 3 units. Well, what thing affects our down movement? Our K value does. Our left and right movement we'll deal with in a second, but we can identify what our amplitude is because we just measure from that midline to its highest point or midline to its lowest point. Well, this one is 4. How about the period? Our period here is, well, that's going to be hard to find. We can do a few things. Either we identify from the middle till it repeats itself back in the middle, go from pi/6 to 5pi/6. Let's see, that would be a total of 4pi/6, which reduced is 2pi/3. Or we could go from our highest point to the highest point, which would be pi/3 to pi, which is, well, 2/3 of pi. Or we can go from its lowest point to its lowest point, which is 0 to 2pi/3. It's still the same period. That does, our period helps identify what our B value is, just like our amplitude helps identify what our A value is. The A's and K's work out really nicely. It's the B and the H that is a little bit more tricky. So our period is affected by the B value. So it's saying 2 pi divided by what number gives us 2pi/3. Well, this one's a quick, easy look at it because it's saying 2 pi divided by what gives you 2 pi divided by 3. Well, B is 3. Now, the reason that I didn't do too much with the horizontal translation is because it changes. It changes whether we're talking about a sine graph or a cosine graph. For a sine graph, because we know a sine graph starts at the middle, goes up, down, and back, we're going to have to identify on here, where does it start at the middle, go up, down, and back? All right, here, at pi/6. It has moved right pi/6. For a cosine graph, we have to identify where does it start at the top, go down and back up to the top. Where does that starting point happen? In this one, it's happening at pi/3. It has moved right pi over 3. When we put it into the equations, because our normal equations are going to be y equals a, sine of b x subtract h plus k, or using our cosine, what we're going to do is we're going to use both equations. We're going to do both equations. We're going to do one for sine and one for cosine with all of this information. For the sine graph, I'm just going to put in what I can. The a value. Well, the a value is exactly what our amplitude is. It's 4. Our b value, well, it's 2 pi divided by b. In this case, it's 3. On the inside deals with our horizontal translation. For a sine graph, we've moved right pi over 6. But that does not mean that we're going to be adding pi over 6. Because the opposite on the inside means it has to be subtracting pi over 6. And last but not least, because it's moved down 3, we're going to write subtract 3. This is not the only answer. For example, we could deal with it as moving right 5 pi over 6, because that way we would still be able to start going up, down, and back up. So this number could also be 5 pi over 6. And there's actually an infinite amount of solutions to this. If we use a cosine graph, again, I'll just plug in the things that I can without anything special. A value is still going to be the same. It's still going to be our amplitude. Our b value is also going to be the same. Our vertical translation, our vertical down, is still going to be the same. The only difference is the fact that it has moved, for a cosine graph, it has moved right pi over 3. We're going to subtract pi over 3. That's not the only answer. We could also write it as having moved right pi units. So both of these answers are perfectly fine. Next one. All right. So first thing I like doing is absolutely identifying what that midline is. That way I can do a whole bunch more information. From that midline, it goes up 3 and down 3. So whether it's a sine or cosine graph, both of them start on the have a midline of the x-axis. In this one, it hasn't moved up or down at all. Our amplitude, though, is 3, which means that's our a value. This one deals with our k value. Alrighty, our period. How long does it take to repeat itself? So we can do a few things. We can measure from the top to the top. We can measure from the center back to the center. We can measure from the bottom to the bottom. In this one, it's probably the easiest to measure from the bottom to the bottom. From 0 to pi, our period is pi. So then the question is, 2 pi divided by what gives us pi? Well, the only number that 2 pi divided by something can give you is pi. B value would have to be 2. We can do some cross multiplication. We can do 2 pi times 1 is 2 pi. Pi multiplied by b, divide by the pi, and b still comes out as 2. Both perfectly fine. Now we can identify what our horizontal movement is. So again, we have to identify it as either a sine or a cosine graph. A sine graph, again, starts in the middle, goes up, down, and back. Cosine starts at the top, goes down, and back up. For this one, the only way we can see that it has started at the middle, gone up, down, and back, is by starting there. Well, what is that point? Well, we're going to have to do a little bit of math. Now we do math and math. That's funny. 0. Looks like this has been split into 4 nice equal sections. Well, that would be 1, 2, 3 of those 4. So it has moved left 3/4 of a pi. For a cosine graph to have started up at the top, goes down and back up, this would be our point, which is half of the way. So left pi over 2. When we plug it into our equations, again, I'll just fill in the necessary parts that are needed. I'll do the cosine at the same time. Alrighty. A value, amplitude, 3. That's the same on both of them. B value, well, our B value is 2, because 2 pi divided by 2 gives us the period of pi. It has moved, the sine graph has moved left 3 pi over 4. To move left, because on the inside we do the opposite, we write it as addition of 3 pi over 4. For the cosine, it would be the addition of pi over 2. Because this has not moved up or down, we don't have to have anything on the outside here. Do want to help identify that these are not our only 2 answers, because we could be starting here or we could be starting here. Well, this one is actually a right movement of 1/4 pi. A right movement of 1/4 pi, which means the inside will be subtracting pi over 4. For cosine, we don't have to start here. We could technically also start here, which means that that would be a right movement of pi over 2. Which means we're subtracting pi over 2 in there. So all in all 4 of these equations are identifying the exact same graph. So I did make a note of it, and I wanted to come back to it, especially right now. It's great. You'll notice that a cosine graph, oh, don't want that there, is actually a sine graph that has just been shifted over. A sine graph that has been translated pi over 2 to the left, because we can still go up, down, and back in the span of its normal 2 pi. So now that we have an understanding of what the graphs actually look like, let's deal with one more thing that talks about its actual equations. Let's talk about a word problem. In here, it says in a Calumet Nunavut, Calumet? Yeah. I apologize if I'm completely butchering that pronunciation. In a Iqaluit, none of it. So the capital of none of it. The hours of daylight can be represented by this function. 8.245 sine of 0.0172 bracket x subtracting 80.988 plus 12.585, where x is the day number of the year. So our daylight hours of daylight, can be calculated by using this. The x value just tells you the day number in the year. So if we have it on an XY axis, all along the x-axis just talks about the day number. Oh, actually, let's just change that. On the y-axis, it talks about the hours of daylight. We have a whole bunch of transformations here. First one is how many hours of daylight occurred in a Iqaluit on the following days. The shortest day and the longest day. So let's deal with the graph of it. So if we are to graph this, we identify a few things. First off, the amplitude is going to be 8.245. Our period is going to be 2 pi divided by 0.0172. And what does that come out to be? So 2 pi divided by 0.0172. 365.30 approximately. Our horizontal translation it is moving right 80.988 and vertical it's moving up 12.585. So if we do this quick sketch of this, we're going to have our midline of 12.585. So that'll be 12.585. From there, we're going to have to move right 80.988. So our scale doesn't really matter. We can say that that's our 80.988. Its period is going to be 365. So from there, so 80.985, add 365.30, we'd be ending at about 446.285. Halfway in between, we're going to have our middle, because our sine graph, because of a sine graph, starts in the middle, goes up, down, and back, but our midline has changed. Our highest point is going to occur here, and its lowest point is going to occur right here. Why did I put it right there? Well, that's because our amplitude is only going to be 8.245. So that span is 8.245. This span is 8.245. So it's going to go up, down, back up. On the shortest day, how many hours of daylight? Because hours of daylight is on the y-axis, it is asking for, what is this point? So we didn't have to do all this work, but all this work does help us with identifying a few more of our characteristics. The amount of hours of daylight on the shortest day, so the lowest amount of hours, is going to be 12.585 subtracting that amplitude of 8.245. So 12.585 subtracting 8.245. There'd be 4.34 hours of daylight on its shortest day. On the longest day, it's asking for what is this point. So this one, 4.34, we're asking what is its highest point. I know it's not to scale, because you can tell that that's definitely not the same as that. But this is also just a rough sketch. 12.585, adding 8.245. Will be 20.83 hours. So on the shortest day, they only have about less than 4.5 hours. On the longest day of the year, they'd have almost 21 hours. In some years, June 21st is the longest day. Oh, awesome. If we suppose that the sun set at 11:01 p.m., what time did it rise? Well, it would have risen 20.83 hours before 11:01. Well, let's do some quick. There we go. It'd be 20.83 hours before. So that's hours. Let's do some conversions to get that into some minutes. Actually, we don't need the 20 part. Let's just find out how many minutes is 0.83 of an hour. So 1 hour is 60 minutes. $49.8, which is roughly 50 minutes. So it'll be 20 hours. 50 minutes before this. So quick calculation, 50 minutes before 11:01. So 11:01, we subtract the 50 minutes. Let's see, 1, that would put us at 49. That would put us at 10:11. And 20 hours before that, so we subtract 20 hours off of that. So because we're dealing with hours, 10 hours before that would be to put us at noon. So 10 hours will put us at 12 o'clock. We'd have 10 more hours, which would be at 2 o'clock. So at 2:11 a.m. is when the sun rose on June 21st, in some years. What is the period of this? Well, our period, we just calculate this here, is 365.30. Well, what is period? Period is on the x-axis, how long it takes to repeat itself. And on the x-axis, it's the day number. Oh, wow, what does that mean? There's 365 approximately 3 days in a year. That's what that means. So the amount of daylight hours in a year is a sinusoidal curve. It is a periodic function. Because it repeats itself over and over. What does the value of 80.988 represent in the context of this question? So what does that horizontal movement of 80.988 mean? What does this point mean? Well, it talks about when does the daylight hours start increasing. When does daylight hours start increasing? And because that's a horizontal movement, so notice how I just put H, I use H, the textbook uses C. But when it starts actually increasing in daylight hours, because it goes up from there, we can identify exactly what this one would be too. But what is this day? Well, let's see. Daylight hours, let's see, January has 31 days, February has 28, so we're already at 59 days. This is about 81, so 81 subtracting 59 puts us at 22. Which means on March 22nd, which is the spring equinox, our days start getting longer. We get more daylight hours in the year. So this really does have a nice application, especially if you're going to start talking about anything weather and start talking about temperatures and everything like that. You can have a whole bunch of calculations. And this is one use of this sinusoidal function. That means you can go have some fun.